Welcome to the very last lesson of Unit 1, the intermediate value theorem. Tomorrow's review day, then you have your tests on Monday and Tuesday broken up in two parts. All right, so this lesson is on what's known as the intermediate value theorem. It's the first of three main existence theorems that we're going to study in calculus. An existence theorem just asserts that a point exists in a certain domain, but doesn't necessarily tell you what that point is. It just says this point does exist. Okay, so first thing to note is that there's a condition to the theorem, and if that condition is met, then the theorem is true. And the condition for the intermediate value theorem is that the function is continuous. Okay, so this is what the theorem states, and just bear with me. If f is continuous on the closed interval from a to b, so from a to b there's no gaps or holes, and this is not really a hole, this is just a point C it's trying to show you. Okay, and k is any number between f of a and f of b. So k is some y value between the y value at a and the y value at b. Then there is at least one number c, so some x value between a and b, such that f of c is k, so that the y value is k. And again, that's only true if the function is continuous. Let me just put that in like regular words, because that was a very mathy formal definition. All right, you've got some point, we'll call it a, and let's make that over here. So, and that would be f of a, the y value at a. You've got another point b, I'll make it up here. So that's f of b, or b of b, f of b. Okay, if you have a continuous function between these 2 points, no matter how you draw it, it could be a straight, that wasn't a straight line, but it could be a straight line. It could be a curve, right? No matter what you do, somewhere between a and b, we make some number c, you have to pass every single y value between f of a and f of b. Okay, you can try to disprove it. You can't. It's always true as long as the function is continuous. Right? If the function is not continuous, then you could have a gap somewhere, right? And then there's no function here at this y value, right? That's why the function needs to be continuous. Okay, but again, you go from point A to point B, you have to pass every value in between. That's what the intermediate value theorem says. Intermediate means in between. So use the intermediate value theorem to show the polynomial function, blah, 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 has a 0 on the interval from 0 to 1. And just to be clear, a 0 just means a root or solution, right, somewhere where it crosses the x-axis or hits the x-axis. Okay, so intermediate value theorem, we want to guarantee there's a 0. So if we can prove that between 0 and 1, the function goes from a positive number to a negative number, then it has to pass 0 in between, or vice versa. If it goes from a negative number to a positive number, then it has to pass 0 in between. Okay, I guess my points were at 0 and 1, so my points were a little off, but you get the gist. Okay, so what we're going to do is find the y values at 0 and the y value at 1, so that we can show that there has to be a value in between them. Okay, let's find f of 0. So f of 0 is x 0 cubed plus 2 times 0 minus 1, and f of 1 is 1 cubed plus 2 times 1 minus 1. Okay. So 0 plus 0, that's negative 1. 1 plus 2 is 3, minus 1 is 2. Okay, so that means our function is going from, let's try it over. F of 0 is negative 1, and f of 1 is 2. So you can see by the intermediate value theorem, we must pass through 0 at some point. Okay, and our statement would say something like this. Since, you got to make sure the condition's met. So since f of x is continuous, and we know it's continuous because it's a polynomial function, and all polynomial functions are continuous. So since f of x is continuous, and I don't write it like this, but I'll show you. Oops, f of 0, which is negative 1, is less than 0, which is less than f of 1, because that's 2. And that's a fancy way of saying 0 is in between negative 1 and 2, right? So you could just say that, because 0 is in between. Well, you got to show that f of 0 is negative 1 and f of 1 is 2, and then you could say 0 is in between negative 1 and 2 by the intermediate value theorem. There must be a 0 on the interval. I'm just going to copy this. On the interval 0, 1. Okay.